Hello and welcome. Today we want to go through the hyperbolic functions, and we're going to deal with some of the hyperbolic identities. And we're not going to prove those identities, we're just going to be using them. Before you integrate or differentiate a hyperbolic function, you need to know we have the following identities. We have sin of ex. Sin of x is equal to ex minus e power x over 2. We have the cosh. They're same with the other trigonometric identities. The only difference is at the end of this we have h. So you can see we have sin cosh of x is equal to e power x plus e minus x over 2. Another identity we have, they are quite similar. We have the tan of x, which is the sin x over cosh x. Another identity we have is called the coch x, which is basically cosh x over sin x. This is equal to 1 over tan with a h, tan x. We have the sec x, which is 1 over cosh x, 1 over cosh of x. We have the cosecant of h, but not what is called the cosec of h. Let's just write it down here. Another identity we have the cosec, or you can write chc, but now you add an h. A h is 1 over sec of x. And then we have the double angle identities, also quite similar to the other identities. We have the double angles to the other trigonometric identities. We have the double angles, and our first double angle will be cosh 2x is equals to 2 cosh squared x minus 1. We have cosh 2x is equals to 1 plus 2 sin squared x. We again have cosh 2x is equals to cosh squared x plus sin squared x. And you can see in the trigonometric identities, cos squared x plus sin squared x gives us 1, but in the hyperbolic double angle identities, cosh squared x plus sin squared x gives us cosh 2x. Another identity that we have is that cosh squared x minus sin squared x is what gives us a 1. We have another identity, it's called we have 1 minus tan with a h minus tan h, tan x gives us secant squared sec. This is sec squared x. We have a squared here. Another one, we have the cosec squared x is the same as the cotangent squared x minus 1. Those are some of the critical identities that you need to know when you are integrating or differentiating a hyperbolic function. And now let's take an example here. We have been given to integrate, and you know, when you're dealing with the hyperbolic functions, that doesn't mean you need to forget all the other rules like chain rule. Most of the time they work together. An example is here. You have been given to integrate from 0 to 1 cot or cos 5x dx. The first thing is to change it into cos 5x over sin 5x dx. And remember that here we're going to use we have a formula that says that if you integrate cos ax, you get 1 over a sin ax. We are going to apply that identity here, and in our case here we're going to make u to be sin 5x. That means du will be 5 cos, this is sin cos 5x dx. If we want to be left with cos 5x, it means we divide through by 5. That simply means that our dx is we have cos 5x dx will be equals to 1 over 5 du. 1 over 5 du. That means we will have, when we replace, we will have from 0 to 1 over u times 1 over 5 du. That is 1 over 5 integral of 1 over u du from 0 to 1. That gives you 1 over 5 ln. This is 1 over 5 ln of u. But we have our u. That means we're going to have 1 over 5 ln of sin 5x. And now we have a limit from 0 to 1. That means we will have 1 over 5 ln of sin 5 minus ln of sin 0. And then you can simplify further than that. Another example that deals with a hyperbolic function. You have been asked to integrate. We have another example here where we have been asked, this is example 2, integrate from 0 to 1 sin squared x dx. We're going to use the double angles. We know that sin squared x is the same as cos 2x minus 1 over 2. And then we substitute the identity just like in the normal integration. Now we are integrating from 0 to 1 cos 2x minus 1 over 2. Now that is the same as a half into, if you integrate, we're putting a half out here, then we integrate cos 2x, we're going to have sin 2x over 2 minus, if you integrate 1 you get x. Our limit is from 0 to 1. Now we expand, we are going to get sin 2x over 4, because we have 2 and 2, minus x over 2 from 0 to 1. And now that becomes sin of 2 over 4 minus a half minus sin 0 minus sin 0 minus 0 minus sin 0 over 4 minus 0. Now you're left with sin 2 over 4 minus a half. So you can simplify here and get an answer. And that's all for the hyperbolic functions. You basically apply those rules and then you can change the equation and solve any other question that you have been given. Thanks for joining us today. Bye.